Hello, welcome to my channel Physics, a complete classroom series. After the end of the video, in description box, you get the link to download the class note of this video. Also, you'll get the link for the next upcoming video. If you subscribe this channel, automatically you will be notified when any new video will be uploaded. Today's topic is electric field intensity due to two thin infinite plane parallel sheets of charge. Let us proceed. Electric field intensity due to two thin infinite plane parallel sheets of charge. Here, look at the picture. One sheet A, another sheet B. They are separated, but they are parallel. The charge density of the plate A is sigma 1, and for the plate it is sigma 2. Both are positively charged. That means A and B both are positively charged sheet. Here, you just look at the picture very carefully. Here we considering left to right direction, that is positive x-axis. It is easy to write with the help of unit vector, and we here give the direction with the help of I cap vector in this situation only. And in our previous lesson, we already know the magnitude of the electric field is independent of the, for this type of, for a infinite charge sheet, the distance of the point from the plane charge sheet. So we can take the magnitude of E1 and E2 same in the region of 1, 2, and 3. That means the value of the E1, value of the E2, and value of the E3 all will be the same. The value of the E1 here, that is related to the first charge sheet of charge density sigma 1, that is sigma 1 by 2 epsilon naught from our previous knowledge, minus I cap because the direction is from right to left. E2, that is sigma 2 divided by 2 epsilon naught minus I cap, that is also from this, because the electric field due to positive charge, that is away from the sheet. Between the two charge sheet, it is second region E1, that is away from the first, and E2, that is also away from the second. And in this case, in this region, E1 sigma 1 by 2 epsilon naught plus I cap, because left to right direction away from this first sheet. And here the electric field E2 due to the second charge sheet, that is from right to left, because it is also away from this positive charge sheet. Therefore, we are writing here sigma 2 divided by 2 epsilon naught minus I1. And another region at the third region, right side here, the E1, that is due to this E1 away from this charge sheet. And obviously, when the electric field independent of the distance, therefore the value of the E1 that will remain same, and that is equal to E1 sigma 1 divided by 2 epsilon naught I cap, that is from left to right. And for the electric field due to the sigma 2 charge density, that is also from left to right, and that is the sigma 2 divided by 2 epsilon naught I cap plus I cap. Now, in region 1, the net electric field will be the electric field due to this first and second, and these will be vectorically added. E1 sigma 1 divided by 2 epsilon naught minus I cap plus sigma 2, it is the sigma 2 here, sigma 2 divided by 2 epsilon naught, it is misprinted, sigma 2 minus I cap, and therefore the total is the sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught whole into minus I cap, that is along the negative x-axis. Now, in both cases, the direction will be the same. Both cases means if the charge densities are not equal, let us suppose sigma 1 greater than sigma 2, or sigma 2 greater than sigma 1. In both cases, the direction will be the same, that is along the negative x-axis, and the value will be this. Now it is one special case. If sigma 1 equal to sigma 2 is equal to sigma, that means the charge densities are same in both charge sheets and both are positive here. Therefore, their value will be equal. E1 and E2, the E2 will be equal. And when we add them, then you will get the answer sigma by epsilon naught, because 2 sigma divided by epsilon naught whole into minus I cap. And that is always along the negative x-axis, that is from right to left, this one. That means when the charge densities are same in sheet A and sheet B, the electric field at the region 1, that will be sigma divided by epsilon naught minus I cap. Now in the second region, again I am saying in the second region, the electric field E1 due to the first charge sheet, due to the sigma 1 surface charge density, that is from left to right, and due to the second, that is from right to left, these two are opposite in directions. And the resultant that will be here, the E1 plus E2 for the second region, that is sigma 1 by 2 epsilon naught I cap plus sigma 2 divided by 2 epsilon naught minus I cap. And if we take the common I cap, so sigma 1 divided by 2 epsilon naught minus sigma 2 divided by 2 epsilon naught into I cap. Now, if sigma 1 greater than sigma 2, that means the charge density here, it is greater than the charge density of the second. Then E1, numerical value of the E1 will be more than the E2. And ultimately the resultant, the field will be from first to second in such a case, and the value will be, in this case, that is sigma 1 by 2 epsilon naught minus sigma 2 by 2 epsilon naught into I cap, from the left to right, in this case. But if sigma 1 less than sigma 2, that means the numerical value of the sigma 1, it is less than the sigma 2. In such a case, the resultant will be from second to first, that is along the negative x-axis, and that will be sigma 2 by 2 epsilon naught minus sigma 1 by 2 epsilon naught along the negative x-axis. That will be the value, and that is in along the negative x-axis, and that will be, in this case, the value will be the same, but direction that will be the along the negative x-axis. Now the special case, an interesting case, if the sigma 1 equal to sigma 2 is the sigma, when the charge densities are in both sheets are same, sigma 1 equal to sigma 2 equal to sigma, so the value will be same but opposite in direction, therefore the resultant will be 0. That is, no electric field exists between the two sheets. That means when both are equally charged, their charge density is same, there will be no electric field between the two charge sheets. And in the region, similarly, third region, the electric field due to the first and second, both are along the same direction, that is along the positive x-axis. In this figure diagram, we are taking left to right is the positive x-axis. Then total electric field, that will be the vector sum. In this case also, sigma 1 and sigma 2, their values, if both are positively charged, there may be either sigma 1 greater than sigma 2 or sigma 2 greater than sigma 1, always direction that will be from left to right, that means along this direction. And when the in the third region, this one, sigma 1 equal to sigma 2, the direction of electric field will be same, but the value will be sigma divided by epsilon into I naught. Note, in place of two positively charged sheet, if we take two negatively charged sheet, then the magnitude of the electric field will be same, just like two positively charged sheet, but directions will be just opposite in each cases. That means if it is also negative, it is also negative. Ultimately, the direction that will be towards this, here the direction according to their values, and here direction towards this. That means the numerical value will be the same in just like two positively charged sheets, but in all cases direction just will be opposite to the first case. Now it is, now case 2, that is interesting one. and it will be used in the capacitor or capacitance. Two thin infinite plane sheets with opposite uniform surface densities of charge. Initially, we are taking these two are not same, and later on we'll discuss what will happen if the charge densities in the first sheet and the second sheet are equal. Two thin, I am reading again, two thin infinite plane sheets with opposite uniform surface densities of charge are held parallel to each other. These are so and infinite long, because we are using the formula that is for the infinite long. Otherwise, there will be age effect at the age, and the value will be not same, and that is not the age effect. We neglecting that age effect. We considering these are very very larger sheet, therefore the electric fields are uniform. And in such a case, now look at the picture very carefully. You can understand all the things if you look the picture very carefully. E1, that is due to the positive charge sheet, that is obviously away from this. That means toward the left. Here also we are taking left to right, that is positive x-axis, and according to that we are using I cap. Otherwise, you can use j-axis, z-axis, or y-axis as you like, or n cap plus n cap minus n cap. But if you take here it is left to right is the positive x-axis, then it is very easy to understand why we are we are writing here I cap and plus I cap. The E1, that is sigma 1 by 2 epsilon naught minus I cap, and E2, that is toward this. Look at the figure, this toward the negative, and here the field E1, that is from the away from the positive, that is toward the second, and due to also this is negatively charged, it is toward the negative. Between the two sheets, the direction of E1 and direction of E2 are always equal, and the same direction from left to right. And at the third region, E1, that is due to this, and the value we are writing here same, because we know the electric field is independent of the distance from the sheet, and therefore E1, that is sigma 1 by 2 epsilon naught into I cap, and E2, look here, the E2 toward the negative, because electric field due to negative charge sheet, that will be toward the negative, and that will be sigma 2 divided by 2 epsilon naught minus I cap. Now, similarly, in just like our previous example, you can again write the reason one, the electric field due to the first charge sheet and second charge sheet, it is in this way, and minus this, and it is a plus this, you get this. Achha, now if sigma 1 greater than sigma 2, then E1 will be along the negative, because it is when the numerical value of the sigma 1 is greater than this, then finally this part will be the positive and it will be remain negative, that means along the negative. Answer will be this, but the direction will be along negative. But somehow if this is greater, sigma 2, the value of the sigma 2 negative charge density is more than the numerical value of the sigma 1, then it is negative 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 plus, that means ultimately that field will be toward the negative this, toward this ultimately. That means at the first region, the direction of electric field, that depends upon the numerical value of the sigma 1 and sigma 2. If it is more, then resultant will be this along right to left, and if this value is more, then this to this resultant will be. Now interestingly, if sigma 1 is equal to sigma 2, and these two are equal, and let us suppose that is a sigma, all these numerical values are same. In such a case, sigma divided by 2 epsilon naught minus sigma divided by 2 epsilon naught into I cap, that is ultimately 0. There will be no field at all. Very interesting. When the charge densities of positive charge sheet and negative charge sheets are same, that is sigma 1 equal to sigma 2, let us have sigma. In this region, there will be no electric field. Similarly, you get this. Similarly, just like region 1, region 3, you get this. When these sigma 1, sigma 2 are unequal, then you can get the some amount of electric field, but that is a reduced amount of electric field. Because always in this region, the direction of E1 and direction of E2, these two are opposite direction. Therefore, always we get the reduced value. The value will be less than either E1 or E2. And when sigma 1 and sigma 2, these two are same, equal, at that time there will be no field here. That means 0. And in such a case, the field that will be only within the second region. In the second region, whatever the value of sigma 1 and sigma 2, the always the direction from the right to left, always the direction from the positive to negative, due to the negative toward the negative, and due to the positive away from the positive. Therefore, at the region 2, we always get the direction plus 2 minus, and by chance sigma 1 and sigma 2, their numerical values are same. In such a case, we get the value, look here at the region 2, and these are same, then sigma divided by epsilon naught and I cap. That means the value will be added, and this direction always from the positive to negative. And we previously, you now can understand, in the third region, the directions are always opposite, and ultimately final direction will be depends upon the numerical value of the sigma 1 sigma 2. If sigma 1 greater than sigma 2, direction will be along the positive x-axis, and if sigma 1 less than sigma 2, direction will be along minus or negative x-axis. And when these two are equal, there will be no electric field. Now we get the observations. We observe that the field due to two thin infinite plane sheets with equal and opposite plus sigma and minus sigma surface densities of charge are held parallel to each other. It exists only between two sheets, and it is sigma by epsilon naught along positive to negative charge sheets and independent of the distance. So is a uniform electric field. This concept will be used in capacitors. That means now our target, most important target, that was what will be the electric field between the two equal but opposite charge density charge sheet. They are kept parallel to each other. Then there will be exist only electric field between the two charge sheet, and that will be the sigma divided by epsilon naught, which is independent of the distance. Therefore, we can say the electric field between the at that time the between the two charge sheet, that is the uniform electric field. And in this way, for any experiment, we can produce a uniform electric field by keeping two parallel, one positively, on another negative charge sheet. Now it is the end of this topic. And for this note, handwritten note, you go to the description box, you'll get the link for it. And after that and next video, the link of the next video also, you can